Okay, so this is the first topic we covered on Monday, March 16th, which was our last full day in the classroom together. We did a mini lesson and we did 10 minutes per topic for 4 topics. So this first one is called slope fields. So what I've drawn here, or what I've outlined here, is just a regular XY coordinate plane. So here's X, here's Y. And each slash represents 1, so we've got 1, 2, 3, 1, 2, 3, and then same in the negative direction, of course. -1, -2, -3, -1, -2, -3. So again, what we're going to be doing is constructing something called a slope field. And what we have, or what I boxed in, is a first order differential equation. And if you want to think about it using Newton notation, it would be y prime equals x over y squared. And what this thing is an equation that describes slope. This is not a new idea for you in terms of what it is from a calculus perspective, but we're going to be doing something new with it. And before we do that, what I'd like to do, I'm going to switch colors here to show this, is I'd like you to think back to algebra when you were a much, much younger student and you had a problem that looked like this, y equals 5x plus 3. And we, of course, know that's a line and it's a linear function. You can connect all these dots. But when you first learn to do it, what you do is you make a table. So you make an xy table and you fill in some points. You might pick 0 for x, and then, of course, you'd say y is 3. You might pick 1 for x, and you'd get y is 8. 2, and you get 13, and so on, and you can go in the negative direction and choose decimals or fractions or whatever. But then you can plot all these points on a coordinate grid, and these dots can then be connected to make a line. We're going to be doing something similar here, but we're going to be doing it with derivatives. So what we're going to be doing is, instead of plotting points, we're plotting little pieces of slope. So again, think of a derivative as a slope. It is a slope, and this equation, this differential equation, describes that slope. I'm trying to draw a star there, but it's not liking my star. So what I'm going to do is go through, and just like we did with our linear function, I'm going to attempt to plot some slope segments. So the first one I'll do, let's do it one at 1, 1. Well, if I take 1, 1 and I plug it into this differential equation, I take an x value of 1 and I take a y value of 1. And that's going to give me 1 divided by 1, which means at that spot I've got a little slope segment of 1. And same idea if I move over to, say, 2, 1. Well, at 2, 1, my x value is 2, so I put a 2 in the top of that slope equation, so my y prime would be 2 on the top, and then I'm going to put a 1 on the bottom because that's the y value, and I'm going to square it. So again, I'm using this template that describes slope as x on the top and y squared on the bottom. So I'm taking every point on the grid and I'm saying what the x value is, put that in the numerator, take the y value and square it, that goes in the denominator, and then that value, which of course in this case would be 2, is the slope. So now what I need to do, and this gets a little tricky, is I need to draw a slope, little slope chunk that's got a slope of maybe 2. And that gets hard to do, right? So on this first one we had a slope of 1, so this is a little slope segment right here, 1. This is a little slope segment of 2. We're going to keep going around, and actually what we're going to do is I'm just going to fill in I'm putting dots where the integer spots are. So that's just my first quadrant, including the axis, and I guess if I wanted to get wild and crazy with it, I could go down here as well as at the origin. And so what I'm going to do is we're going to go to each of those XY combinations, and we are going to attempt to make a slope field. So if I go over to 3, 1, then on the top I've got 3, and on the bottom I have 1 squared, so that would be a slope of 3. So I'm going to go right here, and that would be an even steeper slope yet. So again, slope of 3. And we can keep going through every single one of these dots, and in truth there's ones in between as well. So there's ones at fractional values, but we're just going to stay focused on the whole number or integer values simply because it's just much easier to do. And let's see. Okay, so now I'll go to the point 1, 2. So that one is a x value of 1 and a y value of 2. Well, if I have an x value of 1, so again, 1, 2. So if I look at that point and I say an x value of 1, well, that's going to be a 1 on top, and then a y value of 2. I'm going to have a 2 squared on the bottom, which means I've got a slope of 1/4. So I'm going to go up to 1, 2, and I'm going to attempt to draw a 1/4 slope line. It's going to be pretty flat, so rise of 1, run of 4, much flatter than any of the other 3 I drew. And that flatness comes because I've got that 4 on the bottom and I've got that fraction. Versus having a 1 or a 2 or a 3. So now I'm going to move over to 2, and we'll do 2, 2. So if we do 2, 2, we get the same idea. Our y prime is going to be 2 on top and a 2 on bottom squared, and that's going to give me 2/4, which is really just 1/2 in disguise. So I've got a 1/2 slope. And again, our attempt is going to be to draw those differently. So it's really challenging to delineate between a 1/2 and a 1/4 slope. But we're going to go through each dot and we're going to attempt to get those slopes. So if I move over to 3, 2, I've got a 3 on top, a 4 on bottom. So that's going to be 3/4, so a little bit steeper at 3/4. And then I'm going to move up to my top column of dots. So I'll go to 1, 3. So if I go to 1, 3, then I'm going to plug that in and I'll get a slope of 1/9. So again, really flat slope. 1/9 almost looks like a 0. Kind of erased right there. So I've got a 1/9. Then I'm going to move over to 2, 3, and I would have 2/9. And 3, 3, and I'd have 3/9 or a third. So again, we've got a slope of 1/9, slope of 2/9, and a slope of 3/9 or 1/3. And you typically aren't going to, and I guess if I'm doing this with fidelity, I should put this one in there too. That's 3/4. You're not going to write in all those m equals. You're just going to write in little slope chunks. And if we do that along the dots that fall on the y-axis where the x value is 0, those are all 0. So those are all flat slopes because no matter what y is, if x is 0, we've got a flat slope. And then the nice thing about this one that I've chosen is we've got all these dots in the first quadrant. So now we're going to go over to the second quadrant. And we're going to say, okay, well, y squared, the denominator, won't change as you look from left to right. So those will be the same. The only thing that's different is going to be there's negative values. So there's negative slope. So what was a 1 slope at 1, 1 is now going to be a -1 slope at -1, 1. And likewise, we're going to get a -2 slope and a -3 slope. And then we're going to get our -3/4. We've got our -1/2. We've got our -1/4. And up top, we've got a -1/9, which is a really flat slope. We've got 2/9, but it's a negative, and we've got 3/9, and it's a negative. And again, this is just an outline of what a slope field might look like. And we can go down to the x-axis itself. On the x-axis, every spot on the x-axis, so everything on the x-axis has a y value of 0, which when you have a y value of 0, you got an undefined slope. So y prime on that does not exist, which means we don't put any kind of slope in there. And we can go down to the third quadrant and the fourth quadrant, and likewise we can construct a picture. And actually that's not that much more challenging to do because there's this mirror image quality. We've got all the y squareds. So no matter what you put in for a y value, you're going to square it. X values are either going to be positive or negative. In other words, if I go down in the fourth quadrant, down here, and I look at 1, -1, 1, -1, I've got the same x value on top. So I'll just do one more of these. 1, -1. I've got the same x value on top, but now I'm going to take a -1 on the bottom and square it. Well, that still gives me a 1. So I actually get the exact same mirror image slope field down in the fourth quadrant that I had in the first quadrant. And that's in part I chose this problem because of that nature. It's a little easier to do than if it wasn't that way. And likewise in the third quadrant, I'm going to get the mirror image of what's in the second quadrant, and I'm kind of overlap my space a little bit, but I think by now probably folks are starting to get the idea. So you create this field of slopes, and we call it a slope field or a direction field. And all that is a set of potential slopes you would have at those values. A lot like when we talked about our linear function and we said, well, you connected points and you made a line out of it. Here, what we're going to do is connect those slopes. So we're going to connect the slopes, but we've created an infinite, if we looked at all the spots in between, number of slopes. So we have to choose a path. And to do that, I'm going to switch colors here. To do that, you're going to be given an initial condition. So this is the other part that I did not put in here, but I'm going to write up here. If we then introduced an initial condition, so I'll do y of 0 equals, let's say, y of 0 equals 2. If y of 0 is 2, then what that means is I'm going to put a 0 in for x and my y value is 2, so I get a big dot right here. All you need to do is fix one point, and then from there you're just following the little slope field. So you're saying, well, as I move to the right, I'm picking up slopes. They're getting steeper and steeper and steeper, kind of gradually so, but they're getting steeper. And then to the left, I'm having the same effect happen, and it's a mirror image effect. So I get kind of this rough parabolic shape that's being outlined. And eventually we need to come up with a way to describe what that shape is, but for right now the idea is, okay, can I draw a slope field? So can I come up with the xy coordinates, plug them into the differential equation and generate all these little red slash marks? And then second, once I have those little red slash marks put together, if I'm given an initial condition, can I then pin that dot down, in this case that's 0, 2, and from there trace out the what the curve would look like traveling along my slope field. And if you get those two things from this video, you've got what you need. This is my first attempt at putting one of these together. It will not be my last, but I appreciate it if you could give it a watch and see if it makes sense from what we did in class, as well as if you weren't in class, to give you one of the ideas that we covered, and we'll have more to come. So thanks for checking it out, and hopefully it's helpful.